Thank you for coming. A quick show of hands. Whoever felt like this project started so clean and nice, oh my God, why is it such a mess after a year that I don't want to poke it with a stick? Quite a few hands. Whoever felt like after that they could learn from it and successfully avoid it ever happening again? Not that many, right? So because this is just 15 minutes, obviously we can't discuss all the things that can go wrong, much less give a solution that will solve all your problems. So for this reason, I will try to focus on one problem, which is coming from the mess of thinking in screens. My name is Zsolt. I'm an Android engineer at Badoo. Mostly I work on architecture and tooling. Badoo is a dating app, and over the years we developed more and more dating apps, such as Bumble, Lumen, and Chappy. And this summer we became the Magic Club group. And over the past year we tried to unify our approaches and architecture across these apps. And during this process we had a chance to address many of the things that can make a developer happy and productive versus things that do the opposite. So the problem is that degradation of the code base is not that obvious to catch. So if you look at this green background me, it is slowly animating to red. And it's difficult to catch at what point it is no longer actually green and at what point it is actually red. And the same thing goes for code quality. So it's not a single decision made at any point in time, it's rather a long-term effect of 1% and 1%. And by the time that we realize that it's actually red, it's very difficult to do anything about it. And then this joke becomes painfully true, and then we have anger and depression about the state of our code base. But what do we do instead is we don't pay attention to that. And instead of addressing those things, what we do is we focus on libraries, frameworks, whether we should do MV whatever, all the newest fad. And I'm not saying it's a trap, but it's a trap, or at least a distraction. It's as if your room looks like this. You don't just sit down and hide the pain and start watching a movie and say, hey, at least the pizza is green. You try to focus on what the actual problems are. So let's see what we can do about it in the short amount of time. The symptom I'd like to address today is this coupled mess. So as I mentioned, we have these dating apps, and it makes all the sense to try to reuse a similar piece of functionality across these apps. But because these approaches in these projects diverged greatly, at some point we found ourselves having really great pain trying to extract and reuse a similar functionality across these apps. And on one occasion it took me 2 full weeks just to do that on a very simple, already existing feature. And it looked like this process. So you're going for the banana, right? You want the banana, but you find out that it's being held by the monkey. And the monkey is holding onto a tree. And the tree is part of a jungle. So you find yourself quickly enough running around in circles with a machete and trying to extract a piece of a jungle just so that you can have the banana. And the problem is that even after you do this, you end up living with that part of the jungle that you extracted, right? So it's like importing a ton of junk into your backyard every time that you want a new fridge or TV. And sadly, if the choice is between 2 weeks of pain and then living with a mess as a result, or writing the whole thing again from scratch, then sadly the second choice becomes a much better option, which just further increases code fragmentation, which just further decreases the chance of reusing anything between these apps. And the underlying issue here is coupling. So you first start writing your module or functionality like this, but because you fail to set a really strong boundary around it, what happens is that over time, it starts being coupled to other parts of the code base. And then it no longer exists only on paper. So coupling comes hand in hand with complexity getting out of hand, which many times comes from thinking in screens. What do I mean by that? So we have this bad habit that as beginners, mostly we start developing Android as writing new activities. And then product designers usually give us specifications for new features using full screenshots of the screen. So what we do is we map these screenshots one-on-one to, let's say, activities. And even if it starts simple, in the long run, it can get really, really messy. So at some point, you can find yourself with 1,000 lines of code. It doesn't matter if it's an activity or in an MVP pattern. And this is really painful at this point. And if your code base is in this state, your biggest problem is not which image loading library you want to use, right? And the problem is that layering at this point doesn't really help. So if you go with a classical data domain presentation layering approach, the best that you can do is you divide by 3. But a huge mass divided by 3 is still a huge mass. So what you want to do is to tame the monster and have individually manageable small pieces. So what can we do about that? Some ideas. Your project is not just a whole bunch of classes that you throw together, right? So if you have a house but you want to go bigger, what you don't do is you throw together a whole bunch of houses in a pile, right? But you plan a proper architecture that can support this scale. So what's in between this project level and the classes level? For simplicity, let's just call this modules. And by modules, I mean any kind of encapsulated piece of reusable functionality. And what's the right boundary for them? So as we've seen, it's probably not a good idea to match a screen one-on-one to a module, because a whole screen cannot be a single responsibility over time. And it can easily get out of hand, and it makes it difficult to reuse sub-screen components. So instead, we need to break up the screen to many individually manageable pieces to reduce complexity, and so that we can reuse parts of the screen. Some suggestions for these modules then. First of all, try to aim for a black box approach, which means that this should no longer happen ever. What you're going to do is you want to build an impenetrable wall around this module, and it should have only one single entrance of communication with the outside world. And all the other things are kept hidden as implementation details, so they cannot get coupled. Another thing that you can do as a practical advice is try to make your modules in a way that they do not require deep understanding from anyone who stumble upon them and try to use them. So as a practical advice, you could try to create a self-documenting high-level interface. In our case, this looks something like this. So you have an example module here, and this guy clearly says what its dependencies are that you need to give it to construct it, what kind of inputs it has, what kind of output messages it can report. And then if they mention any kind of entities, only they are mentioned in this interface, nothing else. So anyone who sees this interface doesn't need to browse through all the classes in your module to have a rough high-level understanding how to create this module and what it will do. You can go even a step further, because this module, once set up, it needs to communicate with other parts of your code base, right? So someone needs to set click listeners or reactive subscriptions, for example. It doesn't matter which one. What matters is that if you can make your module responsible to do this once created, then you can save a lot of time for your developers. So in our case, again, if we have these inputs and outputs, what you can see is that we also require a dependency on a reactive source of inputs and a consumer of these outputs. And then this module takes the responsibility of making these subscriptions, which means that any developer creating this module, once supplies the dependencies, do not need to do anything else. In practice, this means that weeks of extraction and wiring can be reduced to minutes of just supplying some dependencies. It's a huge win. Now try to go for a universal approach, which means that resisting the urge to come up with different kind of solutions per level of view hierarchy, and instead try to abstract away from the screen with a single structure that works on any level, or even without a screen. It would be a huge win. Another idea is to apply some constraints. So there's an inner conflict between giving full freedom of choice developers how to implement the internals of a module and unification and ease of maintenance. So if you have 1,000 different approaches between modules, then every developer needs to learn how others think and how they solve the problem. Whereas if you can just discuss and agree some common approaches and libraries, then you make this process so much quicker and easier. Structure. So now we have these modules on a conceptual level. How should we map them to the screens? So you could try, let's say, a flat structure where you take the screen and you extract all meaningful parts into modules. And then you can map them, let's say, like this. The problem is that the number of green parts tend to increase over time, and you will need lots of wiring between them, and it will look like this after some time. So it's not that optimal in the long run. Maybe a better approach is to try to organize this into a hierarchical level of a tree structure. So if I take the whole screen and assign it to this module, but then this module doesn't need to know about the specific details of the screen. What it needs to know is that we have a menu on the screen, and we have some content area. And then this purple level just delegates these responsibilities to these embedded modules, and so on and so on. As I go deeper into the screen, I go deeper into this tree structure. And the benefit is that any level can remain fairly simple and contain only a small number of children, where it just delegates further more implementation details. And lastly, the most important thing I kept for the last is the visibility between these levels. So if we take a look at this screen, this tree, we can arrange it in a way so that every level knows only about their immediate children and nothing else. So as I go deeper and deeper, the same thing applies. Every level knows only about their children. It doesn't know anything about its parent, it doesn't know anything about its grandparent or grandchildren, not even its siblings, which means that it cannot get coupled to them. And this makes reusing the node super easy, exactly because it doesn't care what parent it's nested under. You can just take it, supply its dependencies, and plug it somewhere completely different, be it another node, another screen, or even a different application. And you can do the same with a single leaf node or a whole subtree. The method doesn't really differ in the end. So following these approaches, the primary benefit is that you will have a system of modules where everything looks similar and easy to understand, have reduced complexity, and are decoupled to the minimum. So this will increase the ease of development and maintenance a lot, and also it will increase reusability a lot. But it's not just about reusability, in the long run, it's more about maintenance. Now, these things are worth a lot in themselves, but there are some secondary benefits I would like to mention. First of all, you can achieve with this approach a natural, proper dependency injection scoping. So instead of having one singleton scope in your application, this naturally provides you a way that every node can be its own dependency injection scope. And you can have a much more fine-grained control over object lifetimes. Another thing is coming from the fact that you can just take any node and plug it somewhere else. So in an instrumentation testing environment, what you could do is just drag them and attach them directly to the screen without other parts of the screen otherwise there, which means that you can exclude a lot of noise from these tests and test even in instrumentation tests in isolation, which can reduce the flakiness. If you're looking for implementation in these ideas, here are some libraries. So we took a lot of inspiration from Uber's RIBS framework. And we just loved the core idea of this tree structure with routing and with screen-agnostic nodes that might or might not have a view and doesn't care about which portion of the screen they control, and these deeply nested hierarchy scopes. What we miss, though, is that in their implementation, the tree state is not really restored, and it doesn't provide you functionality of backstack overrouting. So what we did is we created our own fork, and we addressed those issues, and we also added tons of other cool functionality, and hopefully better tutorials. And what you see here is an illustration of the work being done here. So this is the contribution graph. If you check out the library on GitHub at github.com/bedu/ribs, on the left side, what you see is the original implementation from Uber. On the right side of the graph, what you see is our implementation. So it's more like we built it from scratch. We already use it in production, and we would love to hear your feedback and suggestions. This is actually the first time we announced it, so please give it a go. To sum things up, the key ideas today is try to focus on the level between classes and the whole project, create strong boundaries to avoid coupling, Try to abstract away from the screen to keep things similar and to keep things simple. And then in the end, it doesn't really matter if you go with ribs or you go with architecture components, whether you do MVI, MVP, MVV, whatever. As long as you pay attention to these things, probably you're going to be fine. Thank you very much.